Good morning, everyone. Today we will discuss about batteries, the last topic of your basic electrical engineering course. In the last lecture, we have seen the miniature circuit breaker, how it works, what are its components, what are the types of MCB, and we have seen at the end the comparison between a fuse and a circuit breaker. And in today's class, we will discuss about the significance of batteries, why do we need them, and the classification of batteries, and also more importantly, the differences between the two commonly used battery types, the lithium-ion battery and the lead-acid battery. So moving ahead, I'll start with what actually a battery is and small introduction regarding the battery, and next let's go back to small important key terms which are related to battery, and next the reasons why in the recent past you might be hearing that batteries are getting exploded. So we'll look at why the batteries are exploding, and then we'll see the classification between the disposable and rechargeable batteries, and finally the big difference between the lead acid and lithium ion batteries. So let me start with what actually a battery is. Battery is a chemical form of energy. It is more of a chemical material. It consists of two electrodes, a positive and a negative electrode, which are separated by a electrode. The electrode which you are using, it defines a material which the name. In lithium-ion battery, you'll be using a component of lithium, and lead-acid battery, you'll be using the same. So it all depends upon the electrolyte which you are using. So normally, the electrolytes will be composed of different materials, and the electrodes are also composed of different materials. So when a battery, normally this is the representation of a battery. So when a battery is connected to an electrical circuit, sometimes you will represent it like this. So when a battery is connected to an electric circuit, a chemical reaction occurs within the battery. So whatever the alkaline is present here, so when you connect it to some external circuits, so a chemical reaction will be happening within the battery, so which allows your electrons to flow through this external circuits. So this flow of electrons, it is nothing but a current which is flowing in the path. Thereby you can deliver a power. So defaultly, whether you connect it to an external circuit or not, there will be some voltage drop across the terminals. Now, what are the key terms which are related to the batteries? The first and foremost thing, when you buy a battery, particularly I think you might be using your mobiles, right? When you buy a mobile, you'll be looking at the battery capacity, because everybody wants to have a big battery. So if you see a mobile, the capacity of the battery will be mentioned in terms of ampere hours. So the first and foremost thing is battery capacity, normally mentioned in ampere hours. And in case of a mobile, you will mention it in terms of milliampere hours. Normally an iPhone, it varies from 1900 milliampere hours to somewhere around 3200 milliampere hours. This is to my knowledge. And the latest mobiles, the Redmi or Oppo, they may give up to 5000 milliamperes. It will be specified on the rating of that particular mobile. So it means that your battery voltage is constant. It will be operating at some 5.2 volts or 5.3 volts. The voltage is constant. This capacity indicates the energy which it can store and which it can offer you. So it is a total amount of charge able to pass through the device. So normally expressed in ampere hours, where 1 ampere hour is equal to 3600 coulombs. Okay. So now what actually this means? 5000 milliampere hours, or let us suppose if I take 10 ampere hours. What does it mean? Which means that the battery can provide you with an energy which is equivalent to the product of its voltage and this capacity, 10 ampere hours. So now let us suppose I'll take a battery which has 24 volts, 10 ampere hours. Now let us suppose this is a fully charged battery. Now I can provide it with a load of 24 volts. Now the current rating, if I operate it for 10 amperes, I'll get it for 1 hour. Or if I operate it for a 1 ampere load, then I may get the charging for 10 hours. Understood now. So the higher the load you apply, the less amount of time you will be getting for application. That's why if you take a mobile also, you take some 5000 milliampere hours. This is your capacity. If you just use it for chatting or some sort of browsing websites, then automatically you may get it for a longer time, because your chatting or browsing will not consume large amount of current. But whereas if you use it for games like PUBG or any other adventure games, then your battery quickly drains out. Why? Because they consume lot amount of current. So they consume lot amount of power. So they drag more amount of current, which will drain out the battery. So that's the significance. So what is the maximum load which you can apply here? That will be mentioned on the battery. You can't go it for 100 amperes into 0.1 hour. This is not possible, because the current rating will also be mentioned. What is the maximum allowable current? What is maximum allowable load current? So now this is about your battery capacity, and it depends upon how much amount of electrolyte which you are keeping in the battery. If you keep a higher amount of electrolyte material and a bigger electrode, then you may get a greater capacity. Now the second one is your battery lifetime. Battery lifetime is one more important thing. See, a battery lifetime means, let us suppose if you purchase a battery, it will, whether you use it or not, by the end of the year it will lose 20 to 25% of its original charge. By the time of 5 years or 4 years, 5 years, it will be gone. So battery lifetime is nothing but number of, it generally represents the number of cycles and which you can charge or discharge. So if you use it more, then automatically the lifetime will be decreasing. Normally a battery, in my case, all my mobiles generally they do last for 3 hours or 4 hours because of my extensive usage. Beyond that, I may not be able to get a very long charging time, very long discharging time. So even you take this battery capacity, this battery lifetime will be indicated by health. I think in your mobiles, if you do find, you can find it in the battery health settings. I'll show you my mobile. See, my mobile, this is an iPhone. So in this one, if you carefully see, in my battery settings, I can have this battery. See, I can show you this. Yeah, I think it's difficult for you to see, right? If you can see, this maximum capacity is at 75%, which means that even my phone battery is rated up to 3000 milliampere hours. But even if I do go it for a full charge, I'll be only up to 75% of that 3000 milliampere hours, because it is a 3 years mobile. It has got an age of 3 years. So the battery lifetime will be decreasing. After 3 more years, I'll be getting only up to 1500 milliampere hours, even if I charge it to full. So it's all about the lifetime. Even my laptop also, it hardly gives me 2 years of time. After that, it will drain out very fastly, which means that the lifetime has decreased. Normally, it is defined by the temperature. Temperature is one thing which affects the battery lifetime. Okay. And one more thing is, which we normally hear about the battery, is explosions of the battery. Why do batteries do explode? There are so many reasons why batteries do explode. One such thing is, I have tried to mention the most of the reasons. Say, mostly it is because of the malfunction of the battery or misuse of the battery. Both will happen. So when you try to recharge a primary battery means a disposable battery. Disposable batteries are not supposed to get recharged. So when you try to recharge it, then automatically it will explode. Or if you short circuit a battery, see, if I take a battery and it will be having a voltage, right? If I directly short circuit it, what happens is that the current will be somewhere in thousands or hundreds of amperes. So such current will lead to huge amount of heat. So the battery will immediately explode. There is a limit up to how much current it can give. But if you directly short circuit it, then the current will be infinite, right? So this is one of the reasons why the batteries get exploded. And particularly in cars, why do explosions do occur? See, it is because of the short circuits, which does happen most of the times. Whenever there is a short circuit in a car battery, it generates very large currents. And besides, the car batteries, they liberate hydrogen when they are overcharged. because there will be an electrolysis process in the car battery. So they liberate hydrogen. See, normally the amount of overcharging is very small in case of a battery. So that's why you don't get any explosive gas which will be developed there. The gas will be dissipating quickly in case of a car battery. However, when you jump a car battery, a high current can cause the rapid release of huge amount of hydrogen. So if anyone gives a spark there, then automatically the hydrogen goes into, so particularly when you are jumping your battery. So automatically what happens, huge current flows. So huge hydrogen will be developed there. So suddenly if you remove it, a spark may be coming. So if the hydrogen is very large enough in a large quantity, the spark may ignite an explosion. So that is one thing. So otherwise, if your battery is recharged at a very excessive rates, so what happens is the hydrogen which is already present there and it mixes with oxygen. So it can escape within the walls of the battery. So thereby it leads to pressure buildup and the battery may burst. So these things you should avoid when you are using a car. You shouldn't overcharge it or you shouldn't charge it very fastly. And when you are trying to jump the battery, then please be careful with that. Okay. And one more reason why the batteries do explode is that when you try to dispose a battery in fire, normally your battery is a chemical material. When you're trying to dispose it in fire, then automatically there may be a chance of explosion. And the common cause which we see now is overcharging. Overcharging is nothing but you are trying to charge the battery beyond its capacity. So in that case, there will be unnecessary heat which will be generated. So it will lead to explosion. And the rate at which you charge also, this is also one of the most important things now recently, which you are getting explosions. At any cost, what I mean to say is that it's not only the current. You must monitor the charging current, whether it is in prescribed limits or not. And you should handle it properly when you are disposing it. And you should ensure that there is no leakage from the battery. And finally, you ensure the operating temperature of the battery. All these factors do affect the battery explosion. Okay. Now, let's move on to the types of batteries. When we move on to types of batteries, we generally classify them into two types. One is a disposable battery. We call it as a primary battery or a non-rechargeable battery. The second one is a secondary battery, which we call it as a rechargeable battery. So broad classifications is whether you can dispose it or not, or whether you can recharge it or not. So we'll start with the disposable batteries. As the name itself indicates, they are intended to be disposed. Once you use it, you should dispose it. So normally in your home, you will be seeing that in portable devices, just like your remotes, just like your watches, just like your, in the laboratory you might have seen the DMMs. So all these things, they will be using your disposable batteries. You can find A, AA, AAA, and different sizes they will be available. They are generally used in for your communication side also, for everything. For portable devices, you will be using these things. And keep in mind, they shouldn't be recharged because the chemical reactions are not reversible in the case of disposable batteries. You can find so many types of disposable batteries in the market. I have mentioned a few of them. Maybe these are not in your syllabus, but you try to learn these things. See, I have given a big list of, I found it on the internet, and I'm giving you the list of disposable batteries. Okay, these are all the list. See, this is one lithium battery, which is generally used in watches and computer clocks. The advantage of that is it is having a large amount of lifetime. Okay, in digital watches, you are using mercury battery. In hearing aids, here you'll be using zinc air battery. Okay, and emergency applications, you'll be using water activated battery because it is available everywhere. So like that, these are all disposable batteries. Whereas the rechargeable batteries, as the name itself indicates, they can be recharged. That's why they are also called as chargers or recharges or whatever the name you call them. They are called like that. There are different types of rechargeable batteries coming in the market now. The first is lead acid battery, and the second one is lithium ion battery. I'll make a comparison of these two in the next video. But right now, lead acid battery is commonly used in vehicles, alarm systems, UPS, everywhere you see your inverters, you are using lead acid batteries. Why? Because it is very cheaply available, and when compared to all other lithium-ion batteries, etc., if you want to go for 50 ampere hours or 100 ampere hours, it is better to use a lead acid battery. That is very cost. And one more problem is that it has a lower energy density. And one more thing is it is of overweight, very high weight. That's one more problem with the lead acid battery. You can open your car and see that the battery, it will be very heavy weight. And next is lithium-ion battery, the latest trends, which can store a lot of energy in a small size. The advantage is that they are very fast charging, and they are very fast discharging also. So that's fine. In your laptops, in your mobiles, in your modern camera phones, rechargeable MP3 players, you are using now lithium-ion batteries. They can charge very quickly. Even in Tesla electric cars also, you are trying to use lithium-ion batteries now. So the fact is that these batteries, they can charge very quickly. You can't use lead acid battery for an EV. Right? It will take hours of time. I can't sit for hours of time for just waiting for my mobile or laptop or EV to be charged. So I want a quick solution. So here comes a lithium-ion battery. So similarly, there are other types of rechargeable batteries also. Lithium-ion polymer battery, nickel cadmium battery. This is also one of the things widely used, nickel cadmium battery. Before lithium-ion, we used it to have nickel cadmium batteries. Okay, so these are the different types of batteries. You go through them. I have provided you the PPT, and in the next slide we will discuss about the differences between lead acid and lithium-ion batteries, which are widely used.